On August 15th, 1977, Ohio State University's Big Ear radio telescope recorded a radio burst that lasted 72 seconds. Days later, while reviewing a paper printout, Jerry Eman found 6 characters that made him stop. 6EQUJ5. They showed a signal far stronger than the background, packed into an unusually narrow slice of frequency, and apparently coming from the direction of Sagittarius. Eman circled the sequence in red ink and wrote one word beside it: "Wow." That note gave the most famous single event mystery in SETI its name. And I keep coming back to the physical scene itself. No glowing screen, no dramatic alarm, just a strip of paper and a pattern that looked too strange to ignore. The signal rose, reached a peak, and faded in a very particular way. Its strongest reading, U, meant the telescope was receiving roughly 30 times the background level. The whole event appeared near 1,420 megahertz, the radio frequency associated with neutral hydrogen, the most common element in the universe, and a frequency SETI researchers have long considered a sensible place to listen. That combination made the alien explanation feel tempting. A narrowband signal near the hydrogen line, coming from the sky, strong enough to stand out immediately. If somebody wanted to be noticed across interstellar space, this would at least look like the kind of place you'd check. But temptation isn't confirmation. It's only the beginning of the investigation. The characters 6EQUJ5 weren't a coded greeting. They weren't coordinates. They were a compact record of changing signal strength over successive readings. The telescope watched the signal grow, reach its maximum, and fade as Earth's rotation carried the fixed source through the observing beam. And that shape mattered. A radio source fixed in the sky should brighten as it enters the beam, peak near the middle, and weaken as it leaves. The WOW signal did exactly that. It looked less like a random burst inside the machinery and more like something the telescope had encountered overhead. But there's a small correction to the way this story is usually told. The famous 72 seconds may not be the amount of time anything was transmitting. It may simply be the maximum amount of time Big Ear could watch one fixed point in the sky as Earth rotated. The telescope had a viewing window, and the signal filled it almost perfectly. So, hold on. The neat 72-second duration could belong to the telescope, not the sender? That changes the whole feel of the event. It takes away the idea of a perfectly timed cosmic message and replaces it with something more awkward and more scientific. We know how long our instrument saw the signal. We do not know how long the signal itself lasted. The universe, once again, declined to provide a timestamp. After the printout was marked, follow-up searches continued. The signal was observed only once. Repeated searches over the years never reproduced it. No confirmed source emerged, and no explanation, terrestrial or otherwise, was established. That left scientists with no second event against which to compare the first. No independent replication. No chance to check whether the frequency drifted, whether it carried a pattern, whether its polarization behaved consistently, or whether the instrument itself had produced a misleading result. Imagine being Jerry Eman. You know the responsible scientific response is not, "We found them." It's, "Please happen again." It didn't. That missing second act also explains why later searches mattered so much. A sun-like star was eventually suggested as a possible candidate, identified in popular astronomy coverage as 2 Mass 1928198-2640123 after a search using stellar data, but candidate is doing a lot of work there. The proposed star did not turn a broad directional clue into a verified detection. If you ever look up 6EQJ5 and find the original printout, you'll see why the sequence is so memorable. It looks like an alien password, which is unfortunate for aliens and very convenient for human storytelling. What the signal really exposed was the limit of that old observation. Big Ear gave astronomers a strong clue about the general direction, but not the precise position that modern instruments can provide. Its survey design also left less metadata than a current system would be expected to collect in real time. With one archival event, questions about exact location, source motion, and instrument behavior could not be settled afterward. The list of possible explanations is wider and more specific than aliens or a glitch. It could have been terrestrial interference. It could have involved a reflection from space debris. It could have resulted from interstellar scintillation, where intervening material affects the apparent strength of radio waves. Comet-related hydrogen emission was another proposed possibility. And then, in 2024, researchers proposed a natural mechanism with a strange shape of its own. A magnetar flare may have briefly energized a cold cloud of hydrogen, producing intense, narrowband emission that Big Ear picked up as a single burst. A magnetar is an extremely magnetic type of neutron star. A hydrogen cloud usually isn't something you'd expect to imitate a technological signal. But under unusual conditions, stimulated emission, a natural process related to what happens in astrophysical masers, can produce a sharp, powerful radio signal. That proposal gives the old printout a new scientific use. It turns the mystery into a set of conditions that can be examined. For the mechanism to work, there would need to be a suitable transient source, the right line of sight, and an emission process capable of producing the observed intensity. The model also depends on details such as the cloud's density, the flare's energy, and the geometry of the event. So the magnetar and hydrogen cloud idea is a physics-based possibility, not a solved origin story. Its value is that it offers something concrete to test, rather than simply giving the unknown a dramatic label. The ripple from this single burst reached far beyond the printout. Modern SETI searches are built around the checks Big Ear could not perform in the same way: real-time vetting, multi-observatory confirmation, careful instrument diagnostics, localization, and drift verification. That means a promising signal is not treated as a discovery just because it is strong or narrowband. Observers ask whether it appears at more than one site. They test whether its frequency changes in a way consistent with a source in the sky. They compare it with known interference. They examine the instrument itself, and they try to see the signal again. The WOW signal became a foundational case for that kind of false positive analysis. It showed that detectability and meaning are different questions. A signal can be easy to notice and still be extraordinarily difficult to interpret. The details are useful precisely because each one has a limit. The 1420 MHz frequency makes the event a compelling SETI candidate, but the hydrogen line itself does not imply technology. The 72-second duration matches Big Ear's beam dwell window, but it does not prove deliberate timing. And WOW is not a decoded message. It is E-man's handwritten reaction, while 6EQUJ5 is the intensity sequence. That is the discipline hidden inside the excitement. The strange pattern deserves attention. The possible explanations deserve investigation. But every claim has to stay proportional to what the data can actually carry. Honestly, I expected this story to be mostly about whether aliens called. It turned out to be more interesting than that. It is about what scientists do when the universe hands them one extraordinary clue and refuses to hand them a second. Nearly 5 decades later, the WOW signal still sits at the intersection of radio astronomy, technosignature research, and public imagination. It remains memorable because the evidence is vivid: a 72-second rise and fall, a frequency near the hydrogen line, a direction in Sagittarius, and 6 characters on a paper record. The lasting lesson is not that the signal had a hidden message. It is that one remarkable observation can open several doors toward technology, interference, space debris, interstellar scintillation, comet-related emission, or a magnetar-flashed hydrogen cloud, without telling us which door is the right one. The legacy of Jerry Eman's red ink wow is a stricter way of listening. A burst from the direction of Sagittarius must survive the second look, the second observatory, and the test of returning.